The inventor of the nuclear power plant was a genius. You know, it's the size of a walnut, equivalent to 2,000 liters. That's 10 barrels of diesel. That nuclear power plant, how is it used to generate electricity? In fact, nuclear power plants and before us, the biggest difference in thermal power generation, it's the fuel. You have boilers. Nuclear power plants use nuclear reactors. The core structure inside the nuclear reactor building, atomic nuclear reactor. In addition to that, there are also for pumps and to steam generators, and a supercharger. Let's start with a nuclear reactor. It is externally made of carbon steel alloy. An internal reactor is made up of multiple components. The most critical of these are the fuel rods and the control rods. The fuel rod is equipped with a sealed nuclear fuel composed of fuel particles. Commonly used nuclear fuel is generally made of 235. When this neutron nucleus absorbs a neutron, atomic nuclei become unstable and split into two or more smaller nuclei. A lot of energy and multiple neutrons are released simultaneously. These neutrons can continue to trigger the fission of other nuclei. This creates a disadvantage reaction. And the control stick are made of materials that can absorb neutrons. It regulates the rate of nuclear fission. By the insertion or extraction of the control rod, control the intensity of fission reactions in reactor cores. To control the generation of heat energy, cooling water is installed in the reactor. Cooling water surrounds the fuel rods, absorb the heat generated by the fuel rods, make the water temperature of the cooling water reach 320 degrees Celsius. But the cooling water doesn't boil. Because of the water coming out of the reactor. Enter the steam generator. The pressure gas is connected in the middle. Pressure gauge will increase the water pressure to 150 atmospheric pressure. High pressure will keep water from boiling at high temperatures. The principle of a pressure device is actually a high pressure, hot principle. Increase water pressure by generating steam pressure. Water heated from the reactor flow to the steam generator through the pipe. Inside the steam generator, cycling in countless U-shaped pipes, cycle power from these for high power pumps around. The hot water from the U-shaped pipe will be heated. Water outside the pipe, enough to boil the water in a steam generator, generate steam. The process that follows, it's basically the same process as thermal power generation. Steam will enter the turbine through pipes. The blades of a gas turbine are propelled to turn by steam, converting thermal energy into mechanical energy, and further drives the generator to generate electricity. Then through the low temperatures of the turbines, the steam is then cooled through the condenser and become liquid water again, and then it's pumped back to the steam generator. Reheat the water used in the condenser. Same with thermal power or lake water. It's either cooling tower water. And the simple answer is this. The whole process is a nuclear reactor heating water. Heat the water from the steam generator through a high temperature water pipe. Generate steam. After the steam pushes the gas turbine to turn, drive the generator to generate electricity. Steam is cooled into liquid water by seawater. Return air evaporator. It's one of those things. There are 3 water cycles involved in heat exchange. None of these 3 sets of circulating water come into direct contact. So here's the problem. Why not omit the steam generator? Direct use of primary cooling water to generate steam. Push the steam turbine to generate electricity. You can write your answer in the comment area.